And y'all have seen polynomials before, both in this class and other classes. So if you have a polynomial, you can totally use power rule because you're adding up a bunch of power functions. And so we can combine power rule and sum rule and constant multiple rule to find the derivative. For instance, if I were looking at g of x equals 5x cubed plus 7x plus 15, that's a polynomial. So you're absolutely right. Even though this is a polynomial and not a power function, I can still use power rule, but I'm not just using power rule. I'm also using constant multiple rule and sum rule. So then I have 5, the constant multiple just stays there, times 3x squared, plus here it's important to write out that my 7x is raised to the 1 because that's going to be really helpful to me to look at that 1 power coming down. So I'm going to have 7 times 1 times x to the 0, and then 15 is a constant. It doesn't have a power to protect it, so that's just going to be plus 0. So the short answer to your question is yes, but I think it's a good time to do another example of how that looked. So that's taking the derivative. We're done with taking the derivative. Now that we're done taking the derivative, I think it's good to clean up algebraically because no one would ever leave it written this way in real life. So g prime of x is going to be 15x squared, and x to the 0 is equal to 1. So this would just be 15x squared plus 7, and we don't write the 0. So if I simplify it, I can apply it. You're absolutely right. I can apply power rule to take the derivative of a polynomial. So often we have we do the algebraic cleanup, we take the derivative, then we do more algebraic cleanup.